Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope you guys are doing great, having your time. Well people, you can let me know in the chat box if I'm audible and visible to everyone, yes. You can let me know in the chat box if I'm audible and visible to everyone. Just give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you guys or not, yeah? Hello Karishma, hi Ashwarya, hello Chinmay, hi Gaurav, hi Pushkal, hello Shruti. Good evening everyone, good evening. Welcome back to JEE Enthuse, welcome back. Just give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you or not. Hello Tornado, long time. Jeevan, I'll check it out, Perfect guys, perfect. So, as you all must be knowing, today it's going to be our third mock test of your complete chemistry, right? For the ones who are going to write the JEE in 2021, right? I mean the upcoming JEE attempt, okay? And people, before starting the session, the ones who are new to the channel, let me introduce myself. My name is Wassim Bhatt and I'm your chemistry master teacher right here on this JEE Enthuse channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. And at the same time, do not forget to hit the bell icon so that you get the notification of every single session which we are going to take live on this JEE Enthuse channel. Yeah? Perfect. Hello Amir, hi Venkat, hi Vishruta. Hello Karishma, hello Anthony. Perfect guys, so you can let me know in the chat box if you guys are super duper excited about the rank booster part 3, yes? Just let me know in the chat box if you guys are super duper excited about the rank booster. It's going to be our rank booster part 3, yeah? Perfecto. Just give me some fire symbols in the chat box so that I'll get to see the josh of the session first, yeah? Hello Ashutosh, welcome. Hi Ramesh, welcome to the session. Welcome everyone. Perfect guys, perfect. So without wasting a lot of our time, let's get going, let's get started with the first question which is on your screen. The question was asked in JEE Mains 2020 7th Jan attempt. That means last year the question was asked in your mains, correct? A very simple and ordinary question provided you know its concept, yeah? Okay. Perfect guys. Exactly Vishruta, exactly. I'm going to make sure that you write almost 30 mock tests from this channel in your chemistry, yeah? Perfect, let's get going. Let's see how this question is to be solved. The question was asked in your mains 2020 7th Jan attempt, yeah? Understand properly how this question is to be solved. First of all, as per the question is concerned, the solubility product, KSP, of PbI2 is given to me, right? So first of all, I have got PbI2 with me and its solubility product is given to me, right? First thing, PbI2, it would have got dissociated as Pb di positive aqueous plus 2 times I negative aqueous, correct? This Pb di positive, this would have got dissociated as Pb di positive plus 2 times I negative, point number 1, yeah? Now people, understand. Let's assume the solubility of this saturated salt over here is S, okay? So the concentration of Pb di positive is going to be S and the concentration of I negative is going to be 2 times S, correct? This is something which you all must be knowing, the way we used to write the solubility product, right? Let's assume the solubility of PbI2 is S, so the concentration of Pb di positive is going to be S and the concentration of I negative is going to be 2S, point number 1. Point number 2, we are given with the KSP value of this PbI2 as well, and the KSP value of this PbI2 is given to me as 8 multiplied by 10 raised power minus 9, okay? This is the KSP value which is given to me, okay? People, at the same time, the container which contains PbI2 and its ions, in the same container, I have got lead nitrate as well. Well people, if you talk about lead nitrate, it is a strong electrolyte. It would have got dissociated completely into its ions. And its ions are Pb di positive plus what? Pb dye positive plus 2 times NO3 negative. These will be the ions of this strong electrolyte, correct? What is the concentration of this PbNO3 whole twice that's given to me? The concentration of this PbNO3 whole twice that's given to me is 0.1. So initially this is going to be 0, this is going to be 0. Now it's a strong electrolyte, it would have got completely dissociated into its ions. So the concentration of PbNO3 whole twice after some time will be 0, right? Now use the stoichiometry. 1 mole gives 1 mole, so 0.1 gives 0.1. Similarly, 1 mole gives 2 moles, so 0.1 gives 0.2. Okay. So from this strong electrolyte, what is the concentration of Pb dye positive that's coming? That's coming out to be 0.1. Okay. Now people, basically understand, I have got a weak electrolyte and a strong electrolyte present in the same container. I have got a weak electrolyte and the strong electrolyte present in the same container. And both these, weak electrolyte as well as strong electrolyte, they have got a common ion in between them. Okay. They have got the common ion in between them, correct? Now people, due to the common ion effect, what happens to the solubility of the weak electrolyte, right? What happens to the solubility of weak electrolyte? Solubility of weak electrolyte decreases, okay? Right? Due to the common ion effect, the solubility of weak electrolyte decreases, okay? Now people, if I ask you, in the container, what is going to be the net Pb dye positive concentration? It is going to be S plus this 0.1, right? This is going to be the net Pb dye positive concentration in the container. Now, due to common ion effect, I told you few minutes back, I told you due to common ion effect, the solubility decreases, due to which, what I'm assuming S plus 0.1, I'm assuming S plus 0.1 approximately equal to 0.1 only, right? Because the solubility has decreased, okay? And I'm assuming the solubility after the common ion effect, I'm assuming the solubility less than 0.05. So you can neglect this solubility in presence of this 0.1. Okay. Now people, the question is almost done. The question is almost done, right? Now simply, I'm going to write the expression for the KSP of this PbI2. It's going to be concentration of Pb dye positive raised by the stoichiometric coefficient multiplied by concentration of I negative raised by its stoichiometric coefficient, that's 2. KSP value, as per the question, it's given to me as 8 multiplied by 10 raised power minus 8 is equal. Pb dye positive concentration is this much, but instead of S plus 0.1, I'll be only writing 0.1, which means 10 raised power minus 1, multiplied by I negative concentration is simply 2 times S ka square, right? Okay. As simple as that. Well, it's not 8 into 10 raised power minus 8, it's 8 into 10 raised power minus 1. Minus 9, I'm sorry for this. 8 into 10 raised power minus 9 is given in the equation. Okay. Now people understand. I'll simply write this is going to be 8 into 10 raised power minus 9 divided by 10 raised power minus 1. That 10 raised power minus 1 goes up. So it is simply 8 into 10 raised power minus 8 is simply equal to 4s square. So you can say s square is equal to 2 multiplied by 10 raised power minus 8. If you take root on both the sides, you'll be getting the value of s as root of 2 is simply going to be 1.41 multiplied by 10 raised power minus 4, right? That's something which you'll be getting. But people, can I write the same thing as, can I write it as 141 into 10 raised power minus 6? So I got the solubility as 141 into 10 raised power minus 6. Now, if you compare this term and this term, a multiplied by 10 raised power minus 6, 141 multiplied by 10 raised power minus 6, that clearly says a value is equal to what? A value is equal to 141, which is something which I was supposed to calculate, right? So option D is going to be the one which is correct among all. Let me know in the chat box if it is clear to everyone. Yes. Let me know fast. Let me know fast. Exactly. This was the integer type question. Exactly. Give me some green signal from the chat box so that I can move on to the next one. And people, at the same time, these sort of questions are frequently asked in your mains, right? I don't know, for advanced previous year questions, we take a separate series that's called as Killer 5. Okay, you can watch those sessions. Well, this mock test is only for mains, right? It's not for advanced. For advanced, we do the Killer 5 series. That's different. Perfecto. Let's move on to one more question then. Let's move on to one more question. Okay, a very, very simple question which was asked in mains 2020 in the same attempt, 7th Jan session. Okay, You can let me know in the chat box what do you think about this question. Let me know in the chat box first. Let me know in the chat box first. The electron gain enthalpy in kilojoules per mole of fluorine, chlorine, bromine and iodine respectively are. What do you think? What do you think? No, not yet, because I'm jam-packed with the YouTube sessions. Perfecto. Wonderful, guys. So first thing, if I talk about fluorine, then you have chlorine, then you have got bromine, then you have got iodine. Let's not talk about the astatine, right? Well, people, as you all must be knowing, as we move down the group, what happens to electron gain enthalpy? Electron gain enthalpy decreases as we move down the group, right? Okay, electron gain enthalpy decreases. These are the electron gain enthalpy values of these fluorine, chlorine, bromine, iodine, right? This minus sign, it simply indicates energy is being released when an extra electron is added to the isolated gaseous atom. That means when you're adding the extra electron to the isolated gaseous atom of fluorine, at that time energy will be released. Okay? In all the cases, electron gain enthalpy values are negative. Negative sign simply signifies that the energy is released. Point number one. Point number two. Normally, what do we think? Electron gain enthalpy decreases on moving down the group. So, as per the expected order, maximum electron gain enthalpy should be for fluorine, then chlorine, then bromine, then iodine. This should be the expected order, but this is not the actual order. The actual order is chlorine has got more electron gain enthalpy than that of fluorine, then comes your bromine, then comes your iodine. Correct? What is the reason? The reason is fluorine has got the small size, it has got more electron density, due to which the incoming electron, which is going to be added to fluorine, experiences some repulsions from the electron cloud of the fluorine, due to which fluorine has got lesser electron gain enthalpy than that of chlorine, right? As simple as that. Yes. So people, what do you think? Chlorine has got the maximum, followed by fluorine, followed by bromine, followed by iodine. So what do you think, which option satisfies that? It's going to be option B. This is for fluorine, this will be for chlorine. Chlorine has got higher than that of fluorine, then comes your bromine, then comes your iodine. Sorry, yeah, exactly. Fluorine, chlorine, bromine, iodine, yeah? As simple as that. So option second is going to be the correct one among all. I'm sure it's clear to everyone. Okay? Well, Arno, I'll let you know when I launch it. Okay, I'll let you know. Perfecto. Let's move on to one more question then. This is one more question. Among the following, the aromatic compounds are. We are supposed to check which of the following are the aromatic compounds, right? Well, people, what is the condition for the aromaticity? What is the condition for the aromaticity? For the molecule to be aromatic, let me tell you, three conditions are there which a molecule must satisfy, then only we can call that as the aromatic molecule. Yes? Point number one. For the molecule to be aromatic, the molecule must be cyclic, the molecule must be planar, that means all the atoms in the molecule should be sp2 hybridized, and there should be complete cyclic conjugation. There should be complete cyclic conjugation present. Complete cyclic conjugation. And at the same time, the molecule should follow the Huckel's rule. That means the molecule should have 4n plus 2 pi electrons involved in what? 4n plus 2 pi electrons involved in the cyclic conjugation, right? And for the molecule to be anti-aromatic, it must be cyclic. For the molecule to be anti-aromatic, it must be cyclic. It must be planar as well. There should be complete cyclic conjugation, but there should be 4n pi electrons involved in the complete cyclic conjugation, right? These are the conditions for the molecule to be aromatic and anti-aromatic, right? Now, people, if you look at the first case, if I talk about this carbon atom, is it sp2? It is not sp2 because you have got two more hydrogens attached over here. It is sp3 carbon, right? Okay. And whenever in a molecule you get some sp3 carbon, that means the molecule is neither going to be aromatic nor it's going to be anti-aromatic. It's going to be non-aromatic. It's going to be non-aromatic because one of the carbon atom right here is sp3. Point number one. Now, if you look at this, there is first of all the molecule is cyclic. There is complete cyclic conjugation. Point number two, every carbon is sp2, right? And there are 2, 4, 6. 6 pi electrons involved in the complete cyclic conjugation. So it follows Huckel's rule as well. So it is absolutely going to be aromatic, right? Okay. Now, if you look at this one, see, the molecule is cyclic. every carbon over here is sp2, right? And this negative charge, it's in conjugation with this pi bond as well as this pi bond, right? And how many electrons, how many pi electrons are involved in the complete cyclic conjugation? 2, 4, 6, right? So 6 pi electrons we have which are involved in the complete cyclic conjugation, right? So absolutely it's again going to be aromatic, yeah? Now what about the last one? What about the last one? If you look at the last one, yeah? So every carbon first of all is sp2, so molecule is planar, but there are only 4 pi electrons involved in the complete cyclic conjugation, due to which this molecule is going to be anti-aromatic. What was I supposed to check? Which of the following, among the following the aromatic compounds are? It's going to be B and C. B and C is going to be aromatic. That means option 2 is going to be the one which is correct among all. You can let me know in the chat box if it is clear to everyone so that I can move on to the next one. Yeah? Right? Right. Let me know fast. Perfecto. Let's move on to one more question then, yeah? Well, a very, very simple question. It was asked somewhere in IIEEE 2009 when I was in 9th standard, yeah. Okay, look at the question, give it a try, let me know its answer fast. At 400 Kelvin, the RMS speed of gas X, whose molar mass is 40, is equal to the most probable speed of the gas Y. At 60 Kelvin, the molar mass of the gas Y will be, right? Yes? Give it a try, let me know its answer fast. It's a very, very simple question again, provided you know the formula. See guys, as per the question, the RMS speed of gas X, I'm writing it over here, the RMS speed of gas X as per the question is equal to what? Is equal to the most probable speed of the gas Y. Okay? Yes. And at the same time, what all parameters are we are given with? We are given with the molar mass of gas X, right? Molar mass of gas X is given to me as 40 grams per mole. And at the same time, the temperature of gas X is also given to me. The temperature of gas X is given to me as 400 Kelvin. Okay? And temperature of gas Y is also given to me. Temperature of gas Y is also given to me as 60 Kelvin. And I'm supposed to calculate the molar mass of gas Y. Correct? A very, very simple question this is. Yeah? Let's try to check what the answer is. Yes? See guys. How do we calculate RMS speed? What is the formula for it? It's simple. RMS speed is equal to under root of 3R temperature of X divided by molar mass of X. This is the formula by means of which we calculate the RMS speed, right? Is equal to most probable speed. What is the formula for it? It's going to be under root of 2RT divided by, it's going to be temperature of Y divided by molar mass of gas Y. First of all, root gets cancelled on both the sides, RR gets cancelled on both the sides. So you get something as 3 times temperature of X divided by molar mass of X is 40 given, I guess, right? Okay, is equal to 2 times temperature of Y, temperature of gas Y is given to me as 60, right? Divided by molar mass of gas Y we are supposed to calculate. And at the same time, temperature of gas X is also given to me, yeah? Temperature of gas X is also given to me, that is, I guess, 400 Kelvin, okay. Temperature of gas X is also given to me as 400 Kelvin. Now, it's your job to do the calculation, right? Just do the calculation, get the molar mass of Y from here. It's a very simple thing now. Yes, it's going to be 41, it's going to be 40, 10, right? It's going to be 30. 30 is equal to, it's going to be 120 divided by molar mass of Y. So molar mass of gas Y, you'll be getting over here as 120 divided by 30, that comes out to be 4. So 4 grams per mole is the molar mass of the gas Y. I'm sure it's again clear to everyone. Yes? Perfect. Perfect. Exactly. Wonderful. Moving on to one more question then. Okay. Well. This is something which you guys are going to do. I'm not going to do this, okay? Let me know its answer fast. It's a very simple question. It's a very, very simple question. 5 moles of an ideal gas at 1 bar and 298 Kelvin is expanded into vacuum. To double the volume, the work done is. Give it a try fast. No need to do any sort of calculation. I'm telling you, I'm giving you the hint. No need to do any sort of calculation. Again, you are giving me the wrong answers. No need to do any sort of calculation, I'm telling you, right? My God. Still you're saying option B. Guys, let me tell you, first of all, what's given in the question? We have got some 5 moles of an ideal gas at 1 bar and 298 Kelvin is expanded. So the expansion of ideal gas is taking place, right? Expansion of ideal gas is taking place in vacuum. In vacuum, right? And if you remember, expansion of the ideal gas in vacuum is something which we call as free expansion, right? Free expansion. In case of free expansion, the external pressure is always 0, right? P external is always 0. Yes. Okay, the question is done. Expansion in vacuum is what we call as free expansion, right? I'm doing the free expansion of an ideal gas. P external is 0. What is going to be the work done, right? W is simply equal to minus P external delta V. Since the value of P external is 0, that means W value is 0, right? As simple as that, correct? Remember, work done in case of free expansion is always taken to be 0 in case of the ideal gas, yeah? Okay, it's going to be option A, absolutely. Absolutely. Yeah? Basically, what is free expansion? Free expansion is expansion against 0 external pressure. Expansion against 0 external pressure is something which we call as free expansion, yeah? Very simple, correct? Let's move on to one more then. Okay, this is one more question which was asked in, again, IIEEE 2009, right? Okay, so let's give it a try. Let me know what do you think about this question. Give it a try fast. Let me know what you think about this question. You're given with 4 resonating structures. You need to check the stability order of these resonating structures, yeah? Okay. You need to check the stability order of these resonating structures over here. These canonical structures which we have. You need to talk about the stability order. Well, people are saying it should be option 4. Yeah, is that? Is that? Is that? I do not think so. I do not think so. Is that? Give it a try fast. Let me know its answer. Okay, let's see how this question is to be solved. First of all, these are the 4 resonating structures which we have, correct? Now understand. First of all, I'll be counting the number of covalent bonds. I'll be counting the number of covalent bonds in all the resonating structures. Over here we have got 2 to 4 covalent bonds, right? 4 covalent bonds. Right here we have got only 3. Right here we have got again 4. Right here we have got 3. Wherever the number of bonds are going to be maximum, there only stability is going to be maximum. So stability of 1 and 3 will be greater than the stability of 2 and 4. This is something which I have got, okay? Stability of 1 and 3 will be definitely greater than the stability of 2 and 4, correct? Now among 3 and 1, which one is more stable? Understand. Right here we have got the positive charge on nitrogen. Again, in this case, positive charge on nitrogen. So I'm not going to talk in terms of positive charge on nitrogen over here. But right here we have got negative charge on carbon, negative charge on nitrogen. Remember, negative charge on more electronegative element is more stable. Negative charge on more electronegative element is more stable, right? So negative charge over here is on more electronegative element. So first one is going to be maximum stable. First one is going to be maximum stable. So either it's going to be option 1 or it's going to be option 2. First one is maximum stable. After first one, which one comes automatically? 3 comes, right? After first one, 3 comes. There is only one option which satisfies it. Okay, so option 2 is going to be the one. No need to check the rest things, right? 1 is maximum stable followed by 3. Rest, no need to check the others. Or if you want to check the others as well, see, this one and this one we have already checked. Now let's talk about this one and this one. See guys, the number of covalent bonds in both the cases are same, but understand. Right here, we have got what? We have got some, see, it's again a very simple thing, based on the same procedure. Negative charge is more stable on more electronegative element. So over here, negative charge is there on nitrogen, so more stable. So second is absolutely going to be more stable than the fourth one, yeah? As simple as that, right? Yes. Right? A simple thing. Well, IIT, please do one thing. Just drag the video a little back. It'll be automatically a replay for you. Okay? Done and dusted. Moving on to one more. Okay, this is one more question. Oh my God. This was asked in IIEEE 1996 when I was 1 year old. Okay? Give it a try fast. Give it a try fast. Let me know its answer. Let me know its answer. It's a very simple thing. Give it a try. Fast, 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 fast. Let me know its answer. Among the following, identify the isostructural pairs. Isostructural pairs, right? Isostructural pairs. Let me know fast. Give it a try. Yes. Give it a try. Give it a try. Okay, let's try it out. Let's try it out. First of all, I'm given with NF3. I'm given with NF3. So first of all, nitrogen is the central atom. How many sigma bonds we have right here? We have got 3 sigma bonds with fluorine, right? How many lone pairs will be there? There'll be 1 lone pair on nitrogen. Okay, 3 sigma bonds, 1 lone pair. 3 sigma bonds, 1 lone pair. The type of the molecule is going to be what? It's going to be AB3L1, right? Where this A is the central atom, B is what I call as the bond pairs, and L is the lone pairs, right? The type of the molecule is going to be AB3L1, point number 1. If you talk about NO3 negative, if I talk about NO3 negative, so how many sigma bonds do we have? Again, we have got 3 sigma bonds, right? How many lone pairs do we have? We have got 0 lone pairs on nitrogen. On nitrogen, there is no lone pair, right? So the type of the molecule is simply going to be AB3 type. Yeah, it's going to be AB3 type. As simple as that, right? Talking about the third one, BF3. If I talk about BF3, how many sigma bonds do we have right here? 3 sigma bonds. Is there any lone pair? There will be no lone pair on boron, right? Because it has got only 3 electrons in its valence shell. So it is going to use those 3 electrons in making 3 sigma bonds with fluorine. As simple as that. So the type is again going to be what? The type is again going to be AB3. Okay. What about the next one? H3O positive. H3O positive, correct? O is the central atom over here, right? So we have got 3 sigma bonds, correct? 3 sigma bonds. Whenever you need to calculate the number of sigma bonds, remember the number of sigma bonds is always equal to the number of terminal atoms attached. If this is the central atom, how many terminal atoms we have? 3. So sigma bonds 3, right? How many lone pairs we'll be having right here? There'll be 1 lone pair on oxygen. Lone pair on oxygen is going to be 1. So the type of molecule is going to be AB3L1, correct? What about the next one? Okay, people, just look at these things only. Just look at these things only. Just look at these things only. See, understand. See, this is AB3, this is AB3. So these two are isostructural. So BF3 and NO3 negative, these are isostructural, right? Okay, BF3 and where is BF3? BF3 and NO3 negative. BF3 and NO3 negative, these are isostructural. Is there any other case? BF3 and NO3 negative, these are isostructural, right? Okay, and what about NF3 and H3O positive? NF3, it's AB3L1, H3O positive, AB3L1. These are again going to be isostructural. So directly, I should say this is the option, right? Option C is the one which is going to be correct one, right? No need to check the rest. No need to check the rest, yeah? How to calculate the lone pairs? It's simple. See, if you talk about NF3, how many valence electrons nitrogen is having? Nitrogen is having 5 valence electrons, right? How many sigma bonds do we have? The number of terminal atoms, 3. So 3 sigma bonds over here we have. Okay. Now people, out of 5 valence electrons of nitrogen, it has used 3 valence electrons to make 3 bonds with fluorine. So there will be 2 electrons on nitrogen as such. 2 electrons means 1 lone pair. So 3 sigma bonds, 1 lone pair. As simple as that, right? Okay. I'm sure it's clear to everyone. I'm moving on directly to the next question, yeah? What about the next question? Okay, this is the next question which is on your screen. JEE Mains 2014. JEE Mains 2014. Give it a try. Let me know its answer first. JEE Mains 2014. In SN2 reactions, the correct order of reactivity of compounds. The correct order of reactivity of compounds. Khan Shahzad, you can enroll and then you can talk to the operational team. They'll be putting you into my batch, okay? Give it a try. Let me know its answer first. Well, people are saying option 2. Is that? Is that? Is that? Well, people, a simple concept you are going to use over here. It's absolutely going to be option 2. The concept is rate of SN2 is inversely proportional to steric crowding of this carbon. Steric crowding of the carbon. If you look at this carbon, Similarly, if you look at this carbon, right? If you look at this carbon, if you look at this carbon, where is the steric crowding of carbon? Less. Wherever steric crowding of carbon is going to be less, then only rate towards SN2 is going to be more. Steric crowding, that means steric repulsions in case of this molecule is going to be less. So first one is going to show maximum rate towards SN2, right? Followed by this one, followed by this one, followed by this one. So it's absolutely going to be 1, 2, 3, 4 is going to be the order of this question, right? Basit, I have already started atomic structure on NEET Elite channel. There also I'm giving the proper JEE content only. You can watch it out there also, okay? Perfect. I'm sure it's clear to everyone. Yeah? Moving on to one more question. Okay. The freezing point of the equimolal aqueous solutions will be highest for. The freezing point of equimolal. So I have got basically 4 solutions, right? And the molality of all these solutions are same. Molality of all these solutions is same, right? I need to check where is the freezing point maximum. Where is the freezing point maximum? He's not talking about where is the depression in freezing point maximum. He's talking about where is the freezing point of the solution maximum. Okay? Where is the freezing point of the solution maximum? He's asking that, yeah? A very, very simple thing. Right. See guys, there are 2 things. Depression in freezing point is directly proportional to Van't Hoff factor. Okay? Right? At the same time, freezing point of the solution, it's inversely proportional to Van't Hoff factor. Just remember these 2 things. You're done. Wherever Van't Hoff factor will be minimum, there only freezing point of the solution will be maximum. Okay? See, wherever Van't Hoff factor will be maximum, there only depression in freezing point will be maximum. But wherever Van't Hoff factor is maximum, there only freezing point of the solution will be minimum. Okay, these are the 2 relations which I want you guys to remember. Right? So, in this question, we are supposed to check the freezing point of the aqueous solution. So, I'm going to use the second relation. Freezing point of the solution is inversely proportional to Van't Hoff factor. Now, people, if you look at the first case, what is the Van't Hoff factor in the first case? Just look at it. Just see how many ions will be produced from one molecule of it. 2 ions will be produced. That will be C6H5NH3 positive, Cl2 negative. So, Van't Hoff factor in case of first one is 2. Right? When it will undergo dissociation, it will get converted into what? Ca di positive plus 2 times NO3 negative. So from one molecule of it, we are getting 3 ions. So Van't Hoff factor is 3. Yeah. Similarly, Van't Hoff factor right here is 4. Over here, it is not going to undergo dissociation or association. It's a non-electrolyte, right? So its Van't Hoff factor is 1. Wherever Van't Hoff factor is minimum, there only freezing point of the solution is maximum, right? Van't Hoff factor is minimum in the 4th case, so freezing point of the glucose solution is going to be maximum among all, right? Exactly, glucose is the non-electrolyte, its Van't Hoff factor will be 1. As simple as that, yeah? Remember this concept as well. Hello Sohaib, how are you? Long time. Perfecto. Perfecto. Yes, Karishma, I'll be doing that soon. Let me know fast, is it clear? Wonderful. Let's move on to one more question then. Let me see if you can solve this one or not. It's a very, very simple and ordinary question. Now you'll be getting to know what kind of a level is nowadays asked in mains, right? The question was asked in mains 2019, 12th April session. Yeah. Hello, Candy Gaming. He's watching from Nepal. That's great. Welcome, bro. Let me know fast. A very, very simple question. The ratio of the number of atoms present in a simple cubic unit cell, body-centered cubic unit cell, and the face-centered cubic unit cell are respectively. Yeah? Isn't it simple? Isn't it simple, right? Isn't it simple? Absolutely it's simple. See, if I talk about the simple cubic unit cell, then we have got what? We have got body-centered cubic unit cell, then we have got face-centered cubic unit cell. What is the rank of simple cubic unit cell? What is the effective number of particles of the simple cubic unit cell? It's 1, right? 1 particle is enough to form a simple cubic unit cell. In case of BCC, it's going to be 2. In case of FCC, it's going to be 4. So the ratio is simply going to be 1:2:4. Check the options. 1:2:4 is option 2. A very simple and the ordinary equation, right? Okay. Perfecto. Wonderful. Moving on to one more. Well. The question is from kinetics part. JEE Mains 2021, 17th of March. That means this year, right? This year question is March attempt. Give it a try. A very, very simple question this is. Give it a try. Let me know its answer fast. I'm waiting for your answers. Yeah? I am waiting for your answers. Give it a try. Give it a try. Give it a try. A very, very simple question this is. I'm sure you all can kill this question. Trust me on that. Yeah? Well, people are saying it's option A. Some people are saying it's option B. What about the rest of the people? I want answers from everyone. If it's wrong also, no issues. I'll correct you afterwards. Just say it. Well, people are saying, I forgot the formula. Is that? I'm not going to tell you the formula. Then what is the point of the mock test? Perfect. So let's give it a try. Let's see what the answer of this question is going to be. Understand? Well, people, as far the question is concerned, for a certain first order reaction. So basically, I'm given with the first order reaction, right? I'm given with the first order reaction. Let's say the reaction is A gives B. Its order is 1. It's a first order reaction. Okay? First thing. At time t is equal to 0, for example, the concentration of reactant is A0 and the concentration of product is 0, right? It's a first order reaction. I'm assuming the concentration of reactant initially at time t is equal to 0, it's A0, yes, and since the reaction has not started yet, so the concentration of product right now will be 0 at time t is equal to 0, correct? Now, for a certain first order reaction, 32% of the reactant is left after 570 seconds. So after 570 seconds, 32% of the reactant is left. Initially, the concentration of reactant was A0. Now, after 570 seconds, 32% of the initial concentration of reactant will be left. So 32% of A0 is still left in the container after 570 seconds. And the concentration of reactant left in the container is represented by AT. Yeah? The question is almost done, right? So 32% of A0 is simply going to be what? It's going to be 32 divided by 100 multiplied by A0. This is the value of AT after 570 seconds, yeah? Now, the question is almost done. I'll be simply writing the integrated rate equation for the first order reaction. Integrated rate equation is going to be simply K is equal to 2.303 divided by T. It's going to be log of A0 divided by AT. This is the integrated rate equation for the first order kinetics, yeah? Okay. Right? See guys, I need to get the value of K. It's going to be equal to 2.303 divided by T. T value is given to me as 570 seconds. Log of A0 divided by AT. A0 divided by, what is the value of AT? AT is 32 divided by 100 multiplied by A0. Right? 32 divided by 100 multiplied by A0. Can I say A0 gets cancelled out? Now how to solve it? You can simply write K is equal to 2.303 divided by 570 multiplied by. It's going to be log of 100. Log of 100 is going to be 10 square divided by what? 32. 32 is going to be 2 raised power 5. Correct? Now you can simply use the property of log. It's going to be log of m by n, which is going to be what? Log of m by n is going to be log of m minus log of n. Then you can use again the property of log of m raised power n, n log n, right? The question will be done and dusted, right? Let me give you the, I'm not going to do the calculation part from now onwards. You are going to do the calculation part from here, right? Okay, so the correct option of this you'll be getting finally as around 2 into 10 raised power minus 3. Okay, see this is something which we have done, right? So the correct answer of this question is simply going to be 2 into 10 raised power minus 3, since we are talking about the rate constant of the first order reaction, and the rate constant of the first order reaction is always time inverse, right? And the time is given in seconds, so it's going to be second inverse, right? Yes. About Sohail, sir, T को degree centigrade मैं नहीं ले सकते. Bro, this T is not temperature. It is the time. It is the time. It's not temperature, okay? Yeah? Perfecto. Perfecto. Let's move on to one more then. The correct order for acidic strength of the compounds. We are given the compounds and we need to check the acidic strength. The question was asked in your mains 2019 12th Jan attempt. Give it a try. Let me know its answer. Give it a try. Let me know its answer fast. Yeah? Give it a try. It's a very, very simple question. The correct order for the acidic strength of the compounds which are given to us is as follows. Give it a try. It's a very, very simple question. Very, 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 very simple question this is, yeah? Let me know fast. Well, people are saying it should be option C. What about the rest? Is it option C? What do you think? Is it option C? I need to check basically the acidic strength of these acids right here. Yeah? So how do we check it? Remember, acidic strength of the acid, it's directly proportional to the stability of the conjugate base. It's directly proportional to the stability of the conjugate base of the acid. Conjugate base of the acid, right? Okay, acidic strength of the acid is directly proportional to the stability of the conjugate base of the acid, right? So I've got 3 molecules over here. Okay, if you take H positive out from this molecule, you'll be getting something as CH triple bond C with a negative charge over here, right? Okay, this is the conjugate base of this acid. This is the acid, and this one is something which I call as conjugate base of this acid. Similarly, just take H positive out. If you take H positive out from here, you'll be getting something as CH3, single bond C. It's triple bond. This is carbon with a negative charge, right? This is the conjugate base of this particular acid. Similarly, if I talk about the conjugate base of this acid as well, it's going to be simply CH2. It's double bond. This is CH, a negative charge on carbon, yeah? Okay. Now, these are the conjugate bases of the acids which were given to me. Now, I need to check the stability of these conjugate bases. Wherever stability of conjugate base is maximum, there only that particular acid is going to be maximum acidic. As simple as that, right? Yes. Yes. Now we will see. Understand properly. Understand properly. Yeah? This is sp hybridized carbon, right? This is sp hybridized carbon, and this is sp2 hybridized carbon, right? Okay. So I'll say electronegativity of this carbon and this carbon will be more than that of this carbon, right? Okay. And we know negative charge is more stable on more electronegative element, right? Negative charge is more stable on more electronegative element. Yes. So I'll say negative charge on this carbon and this carbon will be more stable than that of this carbon. So I'll say this conjugate base is the least stable among all these 3 conjugate bases. If this conjugate base is least stable, so that means this acid is going to be least acidic. So I'll be giving this as the 3rd priority. Okay. Now among these two, see, we have got CH3 group right here, which shows plus I effect, right? And plus I increases the negative charge on carbon. More the charge in the molecule, more the charge in the on the molecule, I'll say more will be its potential energy. More is its potential energy means lesser will be its stability. So stability of this conjugate base is less than that of this, or I'll say stability of this conjugate base is maximum. If stability of this conjugate base is maximum, so this acid is going to be maximum stronger. So this is something which I'm giving the 1st priority, then comes the 2nd, then comes the 3rd. So this one is maximum acidic. Which option satisfies it? This one is maximum acidic, followed by this one, right? Followed by this one. So option C is the one which is correct among all, right? Just give me some green signal from the chat box so that I can move on to the next one. Yeah? Okay. Perfecto. That's great. That's great. That's wonderful. Perfect. Let's see if we have more questions. Okay, the question is asked in your JEE Mains 2020 5th September. Give it a try. Let me know its answer. Oh, Kunal is saying, sir, I googled your name. So what did you get there? What did you get there? Perfecto. Perfecto. See guys how this question is to be solved. Okay. There's a bit of calculation needed in this question. Then it's done. Okay. See what the question says. Understand properly. I'm given with a reaction. The reaction is X plus Y is in equilibrium with 2 times Z, right? X plus Y is in equilibrium with 2 times Z. Okay. Perfect. Now people, at time t is equal to 0, initially, I have got 1 mole of X, okay, I have got some 1.5 moles of Y, and I have got some 0.5 moles of Z as well at time t is equal to 0, right? Okay. So people, basically at time t is equal to 0, I've got 1 mole of this, 1.5 moles of this, 0.5 moles of this are taken in 1 liter vessel. So this reaction is taking place in the container. This reaction is taking place in the container, and the volume of that container is 1 liter, yeah? Okay. Now people, these reactants are allowed to react, and there will be a stage when equilibrium will be attained. And at equilibrium, it's assumed, it's mentioned, at equilibrium, the concentration of Z is 1 molar. The concentration of Z at equilibrium, is 1 molar. This is something which is given to me. And volume of container is also given to me as 1 liter, right? Now people understand properly. See, first of all, I have got some 1 mole of X. Let's assume out of 1 mole of X, let's assume out of 1 mole of X, some X moles are reacting. So I'll be left with 1 minus small x moles of this reactant. Okay. Yeah, as simple as that. Okay, I'm assuming out of 1 mole of capital X, some small x moles are reacting. So I'll be left with 1 minus small x moles of this capital X at equilibrium, right? Now similarly, 1 mole of X reacts with 1 mole of Y. So X moles should react with X moles of Y. So I had some 1.5 moles of Y. Out of 1.5 moles of Y, some X moles of Y are also reacting, right? So I'll be left with 1.5 minus X moles of Y at equilibrium, right? Now, check the Z as well. See, already you had some 0.5 moles of Z. Now, when the reaction will start, when the reaction will happen, some extra moles of Z would have got formed, right? Because X and Y, they react and lead to the formation of Z. Now, see, 1 mole gives 2 moles. So from X moles, you'll be getting 2 X moles. So these are the moles of Z which will be present in the container at equilibrium. Vikram, this is the English channel. I'm not supposed to talk in Hindi, bro. Okay? Perfect. So I got the moles of each reactant and product at equilibrium, right? I'll be simply dividing these moles by the volume of the container. I'll be getting the concentration of reactants and products at equilibrium. Yes. And volume of container is 1, right? 1 liter. Yes. Volume of container is 1 liter. So whatever are the moles of reactants and products at equilibrium, same will be the concentration of reactants and products at equilibrium, right? Okay. Now people, I'll be simply writing the expression for Kc. Expression for Kc is going to be starting from the product concentration of Z at equilibrium raised power 2, right? Raised power 2 divided by concentration of X at equilibrium raised power 1 multiplied by concentration of Y at equilibrium raised power 1. Yeah? Okay. See guys, the concentration of Z at equilibrium is 1 molar. But what is the concentration of Z at equilibrium? It's 0.5 plus 2x. So 0.5 plus 2x is basically equal to 1. So you'll be getting the value of X from here as, you'll be getting it as 0.25. So 0.25 is the value of X which I got. Okay. If you got 0.25 as the value of X, so 1 minus 0.25 comes out to be 0.75. So 0.75 is the concentration of X at equilibrium. 1.5 minus X, 1.5 minus 0.25, it will be 1.25. This is the concentration of Y at equilibrium. Similarly, concentration of Z at equilibrium, it's automatically given to us, it's 1 molar, right? So I got the concentration of each reactant and product at equilibrium. Okay, so just put these values in the equilibrium constant, right? Concentration of Z at equilibrium is 1 molar, yeah? Is it 1 molar? Yes, it is, I guess, 1 molar, or just a second, guys. At equilibrium, the concentration of Z is 1 molar. Yes, the concentration of Z is 1 molar, so 1 square is 1 only. Concentration of X at equilibrium is 0.75. Concentration of Y at equilibrium is 1.25. Correct? Is equal to what? Kc. This is the value of Kc. But as per the equation, Kc equilibrium constant of the reaction is X by 15. This value is basically equal to X divided by 15. Now you need to do this part of calculation. You'll be getting the value of X from here, and whatever will be the value of X, that is something which I was supposed to calculate. Well, people are saying it's coming out to be 44. Some are saying it's coming out to be 16. Let me check the exact answer which you'll be getting after solving this equation. After solving this equation, you are getting the value of X as 16, right? Okay, so option 1 is the one which is correct among all. I'm sure it's clear to everyone, yeah? Perfect, perfect, perfect. A simple question from chemical equilibrium, right? But the calculation was needed in this question. So you need to be really fast in the calculation as well. Perfecto. Moving on to one more question. A very, very simple question again asked in your mains 2015. Okay, what the question says. See first of all. 2 farad of electricity. 2 farad of electricity. 2 farad of electricity. That means Q value is given to us as 2 farad. which is going to be 2 multiplied by 96500 coulombs, right? Because 1 farad is equal to 96500 coulomb. So 2 farad is going to be 2 multiplied by 96500 coulomb. 2 farad of electricity is passed through a solution of copper sulfate. The mass of copper deposited at the cathode. At the cathode, copper is getting deposited. If copper is getting deposited at the cathode, right? Copper is getting deposited at the cathode, but we know at cathode reduction takes place. So if copper is getting deposited, that means the reaction should have been like this: Cu di positive plus 2 electrons gives Cu solid. Then only this copper would have got deposited at cathode. Now, first thing which I'm doing right here, let me calculate the n factor of this copper over here. N factor of this copper is going to be equal to how many total electrons are exchanged in the reaction? 2 electrons are exchanged in the reaction, divided by stoichiometric coefficient of copper is 1. So 2 divided by 1 comes out to be 2. So n factor of this copper in this reaction is 2. Yeah. Now the question is done and dusted. I'll write something as mass of copper deposited is equal to equivalent mass of copper multiplied by current multiplied by time divided by 96500 as per your Faraday's first law of electrolysis is concerned, right? But people, at the same time, you would have heard something like this as well: Q is equal to I multiplied by T, right? So instead of this I multiplied by T, I can write Q as well. Okay, I'll write mass of copper deposited should be equal to equivalent mass of copper, which is molar mass of copper, divided by n factor of copper, multiplied by I multiplied by T is Q, and in the denominator you have got some 96500 as well. Yeah. What is the molar mass of copper? It's given to me as 63.5. What is the value of Q? Q is simply 2 multiplied by 96500. Okay, divided by n factor of copper is again 2 multiplied by what? 96500. So this got cancelled, this got cancelled. So mass of copper deposited is simply equal to 63.5 grams. Yes, a very, very simple question again this was. So option B is the one which is correct among all, right? Perfecto? Yeah, exactly guys, exactly. Right, one more question. The question was asked in, oh my god, IITEE 1990. That means 21 years back. My god. Give it a try. Let me know. Let me know fast. Jadeep, just try to solve more and more mock tests. More and more mock tests. Try to solve more and more mock tests, yeah? Exactly, Vishruta. It's like 5 years before me, right? The question was asked 5 years before I was born. Give it a try. Oh, 1990 means 31 years back. Sorry. My God. Well, people are saying it should be option C. Yeah? Option C, is that? Let's give it a try. Let's give it a try. Okay. The NaNO3 weighed out to make 50 ml of an aqueous solution containing 70 milligrams of Na positive per ml, right? So basically, I've got a solution of NaNO3. If you know NaNO3 is an electrolyte and NaNO3 is a strong electrolyte, it would have got dissociated as Na positive plus NO3 negative. Okay, I have got a solution of NaNO3. The stoichiometric coefficients are 1:1. So can I say in the solution, whatever will be the moles of Na positive, same will be the moles of NaNO3, because the stoichiometry is 1:1, right? So first thing, in the solution, the moles of Na positive will be equal to the moles of NaNO3, point number 1, right? Now how to solve this question? Understand, it's a very simple question. NaNO3 weighed out to make 50 ml of an aqueous solution containing 70 milligrams Na positive per ml, right? Say, as per the question, in 1 ml of solution, there are some 70 milligrams of Na positive, right? There are some 70 milligrams of Na positive. In 1 ml of an aqueous solution, there are some 70 milligrams of Na positive. Okay. If in 1 ml of solution, these many milligrams of Na positive are there, that means in 50 ml of solution, how many milligrams will be present there? 70 multiplied by 50 milligrams of Na positive. So these are the milligrams of Na positive which are present in 50 ml of solution, right? So it's basically equal to 3500 milligrams of Na positive are present in 50 ml of solution, right? 3500 milligrams, that means simply 3.5 grams. So 3.5 grams of Na positive are present in the solution, okay? So if I ask you how many moles of Na positive will be there in the solution, you will say mass of the solution, which is 3.5 grams, divided by molar mass of Na positive, which is 23. So these many moles of Na positive are there in the solution. And whatever are the moles of Na positive in the solution, same are the number of moles of NaNO3 in the solution. Okay? Right? So I got to know the moles of NaNO3 in the solution. The moles of NaNO3 in the solution is going to be what? It's 3.5 divided by 23. But am I supposed to calculate moles of NaNO3? No, I need to calculate mass of NaNO3. So mass of NaNO3 in the solution is going to be equal to moles of NaNO3, right, multiplied by molar mass of NaNO3. Now the point is, what is the molar mass of NaNO3? Molar mass of NaNO3, see, sodium 23, nitrogen 14, 3 oxygens 48, right? So 8, 4, 12, 12, 3, 15, correct? 2, 1, 3, 4, 4, 4, 8, 85, right? Okay, so 85 grams per mole is the molar mass of NaNO3. So just calculate it, you'll be getting the mass of NaNO3 in 50 ml of the solution in grams, right? Okay, and let me give you the exact value which you are getting from here. The exact value is coming out to be 3.5 divided by 23 multiplied by 85. The value comes out to be 12.9 grams, which is approximately equal to 13 grams. Yeah. Okay. Right. Just if anyone has got any sort of problem in understanding this question, just drag the video a little back. It'll be a replay for you. Okay. Perfecto. All right, a very, very simple. Guys, this is something which I'm not going to show. This is something which you guys are going to do, and let me know its answer in the comment section. Okay, let me know its answer in the comment section. It's a very, very simple question, right? I'm not going to do this. I'm not going to do this. It's the average atomic mass concept, right? Yes. M1 multiplied by A plus M2 multiplied by B plus M2, M3 multiplied by C divided by A plus B plus C is going to be the answer, right? Give it a try and let me know its answer in the comment section, right? Perfect. So we have got one more question right here. Look at the question and kill it. Let me know fast. Let me know fast. Yes, Anshul, NEET mock tests I keep on doing on the NEET Elite channel. Yeah. There is one more channel on which I take sessions. That is NEET Elite channel. Check it out. I regularly take mock tests for NEET people as well. And people, by the way, tomorrow at 8 p.m. sharp. Tomorrow at 8 p.m. sharp, I'll be coming live on Catalysis. I hope you know the name of the channel. Catalysis by Vedantu, and in that Catalysis by Vedantu channel, tomorrow at 8 p.m. sharp, I'll be doing a session, and in that session, I'll be doing some 50 questions, 50 important questions from the chapter electrochemistry, and by solving these questions, your whole electrochemistry is going to get revised. For the ones who are going to write the JEE in 2021, tomorrow 8 p.m. on Catalysis, you can check it out, right? Okay, perfect, guys. So we have got the question. The electrons identified by the quantum numbers n and L can be placed in the order of the increasing energies. A very simple question, right? How do we calculate? How do we check? How do we check the order of the energies of these electrons in these subshells? So first of all, there is one rule called as n plus L rule, right? Whatever, if the n plus L comes out to be, see, for the electron whose n plus L will be more, that electron, that orbital, I must say, will be having more energy. If the value of n plus L comes out to be less, that means simply less energy, right? Bohr-Bury's rule you might have heard of in your atomic structure. Yeah. So for the first orbital, we have got the value of n as 4, L value as 1. So for the first one, n plus L value comes out to be 4 plus 1, 5. For the second one, n plus L comes out to be 4. For the third one, n plus L comes out to be 3 plus 2, 5. Okay. For the fourth one, n plus L comes out to be 3 plus 1, 4, right? Okay, so definitely second and fourth is going to have less energy than that of 3 and 1, correct? Now people, if the n plus L comes out to be same, at that time we will be checking on the basis of the value of n. So wherever n value is less, there only energy is less. Okay, among 2 and 4, among 2 and 4, among 2 and 4, where is the n value less? N value is less over here. So fourth one is going to have minimum energy. Fourth value is going to have minimum energy. Then after fourth, what comes? Second comes after that, right? Then after that, in 1 and 3, in 1 and 3, where is the n value minimum? In the third case, so 3 is going to have less energy than that of what? Than that of first. This is the order of the, am I supposed to talk about increasing order or decreasing order? Arrange the following on the basis of their increasing energies. Okay, this is the increasing order of the energies. 4, 2, 3, 1. 4, 2, 3, 1. 4, 2, 3, 1. First one only, yeah? Very, very simple question, correct? Perfect. Let me see if we have more questions or not. Yes, we have got one more question. The question was asked in Mains 2019, 12th April. Mains 2019, 12th April. A very simple question. We are supposed to take the coordination number. Yeah? Look at the first compound. CO, Cl, ethylene diamine twice. This Cl, it's a monodentate ligand, right? This ethylene diamine, it's a bidentate ligand, right? So, chlorine, this Cl over here, this monodentate ligand, it's going to form one coordinate bond with the central metal atom. Apart from that, one ethylene diamine, it's going to form one ethylene diamine, since it's a bidentate ligand, one ethylene diamine, it forms two coordinate bonds, but we have got two ethylene diamines, so 2 2s are 4. So 4 coordinate bonds are being formed by 2 ethylene diamine particles over here. So the coordinate bonds in total in the first case is 5, and whatever is the value of coordinate bonds formed with the central metal atom, same is going to be the coordination number. So coordination number of the central metal atom over here is 5. Now similarly in this case, we have got oxalate ion over here as the ligand, and it is a bidentate ligand. If it is bidentate, so one oxalate ion forms 2 coordinate bonds. So 3 oxalate ions are going to form 6 coordinate bonds. So whatever is the value of coordinate bonds getting formed with the central metal atom, that defines the coordination number, right? So coordination number in the first case is 5, in the second case it's 6. So 5 and 6 is the fourth option, yeah? Okay. Yes, Chinmay, next week on NEET Lead channel, I'll be starting the coordination chemistry. It was a very, very simple question. Just you should know how to calculate the coordinate bonds. After calculating the coordinate bonds, whatever is going to be the number of coordinate bonds, same is going to be what? Same is going to be the coordination number. HCP is telling, use some English also, sir. Bro, am I talking in Spanish? Yeah? We Enthuse Fan Club, you should, for the organic, you should go for Solomon Fryle is there. Solomon Fryle, yeah? Go for that book. That's good. Perfecto. Let's move on to one more. Okay, I guess this is the last question. The question was asked in Mains 2017. This is a conceptual question, I must say. It looks confusing at the same time, yeah? Delta U is equal to isochoric work, isobaric work, adiabatic work, isothermal work. What do you think? What do you think? See guys, just use the first law of thermodynamics. As per your first law of thermodynamics, delta U is equal to Q plus W, right? Yes, delta U is equal to Q plus W. In case of isochoric process in which volume is constant, if volume is constant, delta V is 0. If delta V is 0, W is 0. So for isochoric process, W is 0. That means delta U is equal to Q. So for isochoric process, delta U is equal to Q. Right? For isobaric process, delta U will be simply Q plus W, and W is simply going to be minus P external delta V. Right? This is valid for what? This is valid for isobaric process. In case of adiabatic process, Q is 0. In case of adiabatic process, Q is 0. That means delta U is equal to W. Delta U is equal to W in case of adiabatic process. In case of adiabatic process, right? Okay. And in case of isothermal process, delta U is 0. If delta U is 0, Q is equal to minus W. Now you tell me which one satisfies it. Which one satisfies it? You tell me among 4. Delta U is equal to what? Is delta U equal to isochoric work? No way. Is delta U equal to isobaric work? No way. Is delta U equal to adiabatic work? Yes, delta U is equal to adiabatic work, right? Option C is the one which is correct among all, right? So people, with this, I'm ending the today's session. So I'm sure you would have liked it. And if you have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, yeah? Okay, and the question which I gave you as the homework, please and please do go through that question, right? And at the same time, let me know the answer in the comment section, yeah? Perfecto. Perfecto. Yeah? Okay, so the ones who have not joined into the JEE 2021 crash course yet, please and please do join into the crash course which will be happening on the actual Vedantu platform, right? And people, this is the best and the last option for you people to crack your JEE 2021. Trust me on that. I have seen people getting enrolled in this, shooting up their rank, shooting up their marks by 40 to 50. Trust me on that, yeah? And in this crash course, what we guys are going to do over here is, I will be covering your whole syllabus before the upcoming attempt of JEE Mains. We'll be covering your whole syllabus in your physics, chemistry, as well as mathematics, right? Apart from that, no need to worry about the test series, no need to worry about the mock tests. Everything is included over here. Everything is included over here. There will be some extra sessions with the experts who will help you out how to solve the questions in lesser time, right? You'll get familiar with the exam atmosphere. So do get enrolled in this as soon as possible. It's going to be highly, highly, highly beneficial for you guys, yeah? Do get enrolled. And absolutely, it's going to be a two-way learning interactive platform wherein you can ask your doubts anytime to your master teachers, right? The batch will be starting on 21st of this month, right? Do get enrolled before 21st of this month, and the link is there in the description box of the video. You need to click on this link. You need to click on the link. Use the coupon code as WSCC. If you're using this coupon code as WSCC, you'll be getting some 40% off, and after the 40% off, you'll be getting this crash course just for 6,000 bucks, yeah? Okay. The link for the enrollment is there in the description box of the video. Click on the video, click on the description box, there'll be a link. Click on that link, use the code as WSCC, you'll be getting some 40% off as well. That's great, Vishruta, that's great. 15 questions out of 20, that's wonderful. And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Well, people, this was all from my side in the today's session. I'll see you guys tomorrow at the same time. I'll see you guys tomorrow at 8 p.m. on Catalysis by Vedantu, right? I'll be doing some super 50 important questions from the chapter Electrochemistry. By solving those questions, I'm sure your entire electrochemistry will get revised, yeah? So with this, I'll take a leave. So see you tomorrow at the same time, 8 p.m. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.